Yeah. Just in time. How's Thursday going so far? Weird? Feeling weird, man? I can't say good, I'm not mean. I'm just squinting. So. I don't know if my nose is crooked or if it's chafing my glasses or what. I haven't found anything to keep my glasses from fogging up. I have a mask on, so. Just a little bit side impact. Glad the week's almost over.
Are you?
Yeah.
You got a goal this weekend?
No, we don't. Our meeting is at the end of the month, so. Yeah. Last year was weird. Normally we would start about now, but last year was weird because of COVID, so we had to start till like November, and I don't know, I guess they're starting a little later this year.
How good are you?
So. It depends on what you're referencing it to. Like if you're referencing it to like a professional bowler, I'm not very good, but if you're referencing to somebody that just goes and bowls every once in a while with their friends, I'm pretty dog good. Yeah, we should.
You ever play Wii bowling?
Yeah, I wasn't that good at Wii bowling. So.
Really?
Yeah, I mean, it was okay.
I was decent. I bet I could work you in some Wii bowling.
You probably could, yeah.
Oh yeah, just a second.
She got like
tennis. Oh yeah.
Yeah, I was a little bit better at tennis.
Oh yeah, it's hella hilarious. So funny.
No, they just like swing it. They just like. I'm like, okay.
The sword fighting with mom. All she would do is
No,
sit
the
there
boxing
and
one. I thought I was so bad. Oh, I really was a baddie. I was like, I'm giving up.
So the new place in Oxford is supposed to have bowling alley, right? So,
really.
Most are opening it over the summer, but they're opening it for like banks now. So they're like family days right now, so they should open next month
sounds good.
for the pubs.
Yeah, it looks crazy.
The water's all kind of bougie.
And we've got the new place in Gadsden, but it's okay. I mean, it's nice. Like if you just want to go something bit for it, as far as just a place to bowl. But the closest other places are pretty far away. So.
Bowling Talladega is kind of ghetto.
Boaz.
They got pretty good nachos though.
Yeah.
I've been in 10 years. So.
Yeah, actually, I've never been to that one. Yeah. Boaz, I think that's the closest, and then for
Yeah,
me,
Hill City, but the ball's like that big.
and then Trustful, I guess would be.
Super scary. I feel like I'm gonna die every time.
Us gamers, they're fun.
I know, it really is.
I went there for a couple birthday parties and called it. And had a birthday party there.
And a CD.
Yeah, I still have a CD. I still have
I
a
don't know if it's like me, I was in there for
It's pretty good.
it was somebody's birthday party. But I was doing like really bored.
I all remember that teachers.
You know, I was way too fast. Yeah. I swear, one time I was in the bathroom and I was trying to get out of the bathroom.
Get this function. X cubed minus 1 over x minus 1. You're probably rusty on this. But tell me what you know about what that graph's gonna look like. Anything? That's okay, it's a rational function, that's one that's easy to forget. All right, let me lead you down the trail I want us to go. Oh, what about the domain? See any x values that will give us trouble? 1. Because why? Yeah, if you put 1 in, then you get 0 on the bottom. So here, x can't be 1. Everything else is in the domain. If x can't be 1 at x value of 1, we would say this function is undefined. So let's take a look at the graph. The online graph thing that I like to use all the time is Desmos. It's really good. Alright, let's see if I can get this thing typed in here. I don't like doing it with a touch screen, but hang on, there's a projector mode on here that makes it show up a little better. I just gotta find it. Somewhere. We can see that pretty good. There's a graph. What would you call that graph? Like we're just talking about the shape. Parabola. But what do I say about it? Not exactly a parabola. What's going on with it? It's different than regular parabola. Talked about it. It's not showing up on the graph. We talked about it. Remember? Yeah, this. Undefined at x equals 1. Not showing up on the graph. It won't show up on your calculator if you do it that way. So that's something you have to be careful about. Technology is great, but it's not as smart as we are sometimes. That really what's going on, and if you, I don't know, if you drag right to x equals 1, oop, there it was. It says undefined. Well, I can get it right on it. But it's not showing up. So usually when you make a graph like this, again, what would it be? It would be 1, 3. And Oh, hang on. Well, okay, pretend it's an open circle. I forgot how to do the open circle here, but that point's missing. Blue point should be open. I have to mess with that later when remember how to do that. That point's gone. Okay. So what we want to know, and this is going to seem really easy. It's going to seem really easy right now. But some situations like this are not as easy. So we're starting with really easy and we're working our way up. What we want to know, this function is undefined at x equals 1. We can get no answer out of it. What we want to know is what would the y value be if our function was defined at x equals 1. Well, anybody got an answer? So if our x values was 1 and we could do that with this function, what would the y value be? Don't overthink it. This is 3. Yeah. 3. Okay. So does that make sense? Be 3 because this is the point that's missing, and we can tell that it would be if our x value was 1, it would have to be where it would belong, right? So intuitively, if we think about it, okay, we can kind of get that. We can see, well, this point's missing, so if it wasn't missing, it would be right there where it's missing. It's almost so easy that it's confusing. But what we want to do is we want to develop a way to, or we want to have a method for being able to answer questions like that. There's a couple of ways we're going to look at doing that. And then we'll apply those same methods to this situation when it's not so easy to just look where it's coming. And this thing that we're doing is what we call finding a limit. So what makes this one more kind of intuitive here is we can think about, okay, if we want to know what the y value would be, right at x equals 1, let's look at what's going on close to x equals 1. So, like maybe we pick a point, if I get on there, point here, if I can hold my finger still. Okay, so at 0.52 for our x value, okay, we'll switch to 0.53, 0.54. Okay, what's our y value close to? 2 is getting close to 2, and if we move up, get more toward a y value of, x value of 1. Okay, we've overshot 2. We're getting close to 3. As we get closer and closer and closer to that blue point, what's our y value getting closer and closer to? 3. 3. So we were right. That's another way of explaining it. And then if we come in from the other way, the same thing happens, right? But if we go on the other side, instead of our y value being too small, it's too big. Right? And as we move closer to the x value we want, our y value gets smaller. But the idea here is, where do we end up? Right, we get closer and closer and closer. We end up close to 3. Right? End up close to 3. So we end up close to the same answer coming from both directions. And it doesn't matter how much we zoom in. That looks like, I can only move my finger in such small amounts, right? But let's zoom way in. Okay. Now we're at between 0.95 and 1. Well, same thing happens. Okay. It's just we're just dealing with more decimal places. Right? It's still 2.9 something that's close. We're still getting closer and closer and closer and closer. And the same thing happens coming from the other side. We just get closer and closer and closer and closer to 3, and then we could zoom in to the same thing. You see, we're really close to 3. We can't get to 3. Why can we not actually get to 3? Because our function's undefined there. But we can get as close to 3 as we want with our y values. See if I can get the, I'm going to have to zoom in a little bit more. I was trying to get to max out the 9s there. 2 point. Alright, it's not plotting us quite enough points to get there, but we can get as close to 3 as we want, coming from either side. I guess that's as close as it's going to let me get there. And all that's doing, sliding the point around, that's saving us from having to plug in numbers to the function. We could do the same thing. We could, like, if you look in the book, we're on page 48. If you look in the book, I've got a table of values. Like for x, they plug in 0.75, then 0.9, then 0.99, and then 0.999. And then they do the same thing coming from the other direction. So they start too big at 1.25 and then try 1.1 and then 1.01 and 1.001. They're just getting closer and closer to an x value of 1. And then we see if we can pick out a pattern about what's happening to our y values. So the idea here is we can get as close to the number as we want, or we can get as close to a y value of 3 as we want, but we can't actually get there. So what we call that y value of 3, the actual spot, the target we're aiming for, we call that the limit of the function. Because we can't actually get there, but we can see we've got a pattern that that's where we're headed. We can get as close as we want to, even though we can't. That's the limit. Let's look at let's do this other function. Let's see on this one. It's over x plus 1. Nope. I'm sorry, I'm way zoomed in. What's going on with our domain? Values, we can't. Okay. Use the graph to help answer that. All right, so bottom, if this part turns into 1, right, then we'll have 1 minus 1. What would make this part be 1? Again, 0 over 8. We'll have square root of 1, which is 1 minus 1. That won't work, so if we look here, this point's really not there. Can't use x value of 0. Point that's missing, so 0.02 actually missing there. Supposed to be. I think it's got the medium touch screen. I'm not getting all the options. Black, we'll have to go black. Okay. That point's not really there. And then what other x values don't work? What's the other thing? We don't want 0 in the denominator. On this one, we also have to consider the square root. What can we not use in the square root? Negative numbers, so what values of x would make our square root negative? Negative. What about negative 1? We're okay, but what if we go like negative 1.1? Then we'll get negative 0.1. Alright, so it starts a little bit before we get to 2, but it starts small. Let me ask it this way: what's the smallest x value? Remember how to find that? So if we're not sure, we take what's underneath the radical. You're good. Oh. If you nailed everything perfectly on every little question I asked, it would be pointless for you to be in here. So we take what's under the radical. What was it? Plus 1. So we take the piece under the radical, that's called the radicand. And we know that that needs to be greater than or equal to 0. So if we solve that, that says our x values need to be greater than or equal to 1. Just subtract 1. And we can see that on the graph too. Because if you look at the graph, we don't have anything past left of, because it's undefined over there, and it's undefined. And we can tell intuitively, we can figure out that the point that's missing is the point 0.02. But if it wasn't that easy, then we could do the same thing we did on the last one, right? We could plug in the x values smaller than 0 and get closer and closer and closer to 0. See where we're headed. It looks like that's getting pretty close to 2. I don't know why that's flipping around like that. And if we come in from the other side, we're getting closer and closer and closer to 2 also, even though we're right at 2. Right at 0, I mean. If I can get on it. Fat finger. Okay, you believe me. This. You got the idea of what we're doing, finding that point by coming in from both sides, and we see where the graph was headed, even though that point's missing. That's finding a limit there. Let's think about this other situation here. One more, just trying to get in your head what we're doing. So let's think about this function. It's piecewise, but it's an easy piecewise function. It says if our x value is 2, our y value is going to be 0. Our x value is not 2, every other number, y values. So what does that graph look like? It's going to be easier for us to just sketch it out than try to type that in. What's that graph look like? Well, at almost every x value, what's our y value? 1. So here at a y value of 1, we've got a line, horizontal line at 1. Supposed to be flat. Except we got to take one point out. Which point doesn't follow that? Our x value is 2, our y value is 0. So if we go over to x value of 2, we're going to have to take a point out. So I'm going to do different colors so we can see it. So right here, this point's really missing. It's not on the line. Where's it at? It's down at 0. So it's down on the x-axis. There's what that graph looks like. We just got a horizontal line at 1 at every point except for this one. So this is a little bit of a different situation because our function is defined everywhere. The domain is all real numbers. But we have a little bit of, because if we just say what's f of 0, I mean what's f of 2, easy to answer. What's it going to be? Gave it away when I messed it up. You have f of 2, so we're going to plug in 2. So then we look at our rules. Okay, so here this one says if we're using 2, our y value is 0. So f of 2 is 0, but we're looking at the rest of the function, that's not the same thing as what we would say our limit is. Because, look at this, if we're coming in from the left side, these x values are y values 1, 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 y values 1. Coming in from the right, what are our y values? 1, 1, 1, 1, 1, 1, 1, 1. As close as we want to get to an x value of 2, we get. So here, it's not that our point is missing from the graph, not that it's undefined, but it's that if we just think about the limit, we get a limit of 1. Even though if we actually plug in 2 for x, different situation. Does that make any kind of sense now? A little bit? Kind of see what we're doing? Okay. So, look at another situation. So, new function. Function. We get weird functions because we're trying to look at weird stuff happening on the graph. So. This one, we got absolute value of x over x. So we can. This one's not too hard to type in, so we'll type it into our graphing program here. Maybe. Over x. Or let you see the rest of it. Do this actually. You get an idea of what this one's going to look like? Let's think about plugging in some points. If we plug in 1 for x, what's our y value? Come on now. Let's write it down. Yeah. Plug in 1 for x. Absolute value of 1 over 1. That is what? What about 2 if we plug in 2? We get absolute value of 2 over 2. No, not 2. 1, yeah. That's easy to. Got all those t's in there, alright? How about this one? 1. Okay, what if we do f of negative 1? Then we get absolute value of negative 1 over negative 1. So on the top we get positive 1. Bottom we get negative 1, so that's.
Upper school students and teachers, excuse us an option. Hopefully we have the bells worked out, but if not, at 9:04 is when we would move into chapel schedule. 10th through 12th graders, you'll be in the sanctuary. 7th through 9th, you have these 4 options. You're in the junior beta, that would be mostly 8th graders, I believe. You'll be with Ms. Badgett. On string art with Ms. Manchin, there will be a limit on how many can participate. Ms. Medellin,
What's that one gonna be?
Games Club, and Ms. Brown will do a Pixar Film Fest. So that'll be in about 8 or 9 minutes at 9:04. Thanks.
Man, that didn't really apply to us. And then see any X values that would cause us trouble, since that wouldn't be in the domain? What can we not have down here? 0, have 0 over 0, undefined. So we're undefined at x equals 0. For positive x values, our answer is positive 1. For negative x values, our answer is negative 1. So, looking at our graph. We'll get purple's kind of hard. Here we go on at negative 1. And then right at 0, our function's undefined. So, right on the y-axis, we don't have a point. So, what happens if we try to find the limit at an x value of 0? And if we come in from this side, we're looking at how our y values are changing. All of our y values are what? 1. But if we come in from the other side, all of our y values are negative 1. So what would we say our limit is there? That's a question we need to think about. Since they don't match, we have a problem. So what we say in a situation like this, where if you come in from the left side, come in from the right side, the numbers you're approaching are not the same, we say the limit does not exist. There's not a limit at x equals 0. One way they can not exist. So if you come in from one side and you get toward one answer, and you come from another side, you get toward another answer, and they don't match, then the limit does not exist. Two more ways that a limit cannot exist. Okay, I'm going to hit those real quick and that'll be done. Okay. So let's look at another question. One over x squared. So again, our function's undefined where and if we try to come in from the right side toward 0, come in from the left side toward 0, and see what our y values are going to do, we have an issue here because what happens? We're coming in. What are our y values getting close to? We don't have a good answer, right? They're just getting bigger and bigger and bigger. We'll come in from the other side. Oops. From the other side, getting bigger and bigger and bigger and bigger. And it doesn't matter how much we zoom out. What happens? They're just getting bigger and bigger and bigger. That's so steep, it's not picking up. Doesn't matter, they just grow. So it's not approaching a number. So here, this graph, when you get close to 0, this thing shoots off forever up both directions. We're not approaching a number. There we would say the limit does not exist. We would say that that function is unbounded. There's no bound on how big it gets. Unbounded growth there. And then the most interesting one, we don't see as much. Take this one out. What's going on there? A sine of 1 over x is the function. Let's zoom in a little bit and see if we can tell what's happening there around 0. So our issue is if we try to plug in an x value of 0 again, it's undefined, right? Add 1 by 0. So it's kind of crazy in there. I'll zoom in and see what's happening. That didn't really help. Let's zoom in some more. See if we can zoom in some more. Let's try some more zoom in here. That's it. Zoom in some more. Zoom in some more. We're really not getting anywhere. One of those, they get so close together it gets solid, but it's really just a bunch of lines. And it's kind of like one of those infinite hallway drawings that comes around. So, what's happening? If we try to follow our graph and see where we end up at 0, it's just bouncing back and forth. And it starts bouncing faster and faster and faster when we get close to x value of 0, both ways. So we're not approaching a number, it's bouncing back and forth between a bunch of numbers. So we'll call that oscillation. We have an oscillation in our graph. That is another way that we cannot have a limit. Okay. All right, so we will practice finding some limits. Okay. Tomorrow. Okay. Those coming up next. We got about 2 minutes. We'll see if the bell rings.